Hi everyone, this is Easy Math. Today in this video, we'll see class 6. The topic is properties of whole numbers. We know what are whole numbers and natural numbers. What are whole numbers? They are denoted by the letter W and they are 0, 1, 2, 3, etc. It goes, there is no end for the number system. It goes on and on. This set of numbers is called the whole numbers. Now we'll see the properties of these whole numbers. We are going to learn about 4 and plus 1, 5 properties we are going to learn about whole numbers. They are closure, commutative, associative, identity, and then comes the distributive property. So we are going to learn about 5 properties with the definition and example. Now what is closure? Closure means if A and B are whole numbers, A and B are any two whole numbers from 0, 1 to 3, etc. And it can be any two numbers. Then A plus B is always a whole number. When you add two whole numbers, we get a whole number. We'll see for an example. Suppose if we are adding 2 is a whole number because it is there in the set of whole numbers. 2 is there, 3 is there. It goes on, etc. You can take any bigger number also. For example, okay, we'll take 10 also. 2 plus 10. 2 is a whole number, 10 is a whole number. 10 plus 2, 12. It is also a whole number. This number, is it there in the W or not? After 10, we get 11 and 12. So this sum of two whole numbers is also an whole number. This is the meaning of closure property. So closure property is true for addition. Now we'll see the closure property for subtraction. If A and B are whole numbers, then A minus B is not always a whole number. We'll see an example. We are subtracting. From the whole numbers, you take two numbers. We'll take 3 minus 1. We'll take 3 and 1. 3 minus 1 is 2. 2 is a whole number. Now you take 3 and 10 like this. 3 minus 10. Same 3 and 10. Take 3 and 10 or 2 and 10. What is it? From 3, can you subtract 10? No, it's not possible. You will be learning. The subtraction is possible. They are called integers. You will be learning in later this year. So if you subtract this, you will get the answer in negative numbers. This is not in the set of whole numbers. So when you subtract two whole numbers, the answer is not always a whole number. So the subtraction is not true for closure. Okay, next we'll see for multiplication. That is, if A and B are whole numbers, this is if A and B are whole numbers, then A into B is always a whole number. What do you mean by A into B? When you multiply two whole numbers, we get a whole number. Shall we see an example? So from the set of whole numbers, you take two numbers. For example, shall we take 5 and 6? Yes. What is 5, 6 are 30. Will this 30 be there in the whole numbers? When you go 12, 13, 14, when you go etc. Definitely 30 is there in whole numbers. So the product, when you multiply two numbers, the answer is also a whole number. So next we'll see for division. If A and B are whole numbers, then A divided by B is not always a whole number. Let us check with an example. It is not true for division, just like subtraction. It is not true for division. We'll take 6 is a whole number. Divided by 2 is a whole number. What is 6 divided by 2? Yes, it is 3. 3 2s are 6. Now you take 6 divided by 5 will take. Can you divide 6 by 5? 6 divided by 5. Is it a whole number? It is a fraction. It is not in the set of whole numbers. 6 and 5, we cannot divide exactly. So the answer is a fraction. We have numerator and denominator. This is not in the set of whole numbers. So division is not closed. So division, the closure property is true for addition and multiplication and not true for subtraction and division. Now we see the second property, which is commutative. What is commutative? See, I have written properties written here for addition. A plus B is equal to B plus A. A plus B is equal to B plus A. What does it mean? The first number has become the second number and second number has become the first number. See, I have given example 3 plus 5 is equal to 5 plus 3. What is 3 plus 5? 3 plus 5 is 8. What is 5 plus 3? Is also 8. So even if you change the order of addition, order of the numbers, the sum, S-U-M, sum means what? The addition of two numbers will not change. So this is commutative property for addition. So we'll check it for subtraction now. Same thing, we are going to each property, we are going to check for all the 4 operations. We are going to check for addition. Now subtraction. A minus B is not equal to B minus A. Here both are equal in addition. Let us check in subtraction. If we take, for example, take 4 minus 3. What is 4 minus 3? It is 1, we know. Then what is 3 minus 4? From 3, can you cut 4? It is not possible at now. But later, once you learn about integers, this answer will be minus 1. You will get this. You will be learning it later in 6th standard about integers. So now at time, now it is minus 1. So 1 and minus 1 are the equal. They are not equal. So it is not true for subtraction. Now next is the same property we are going to check for multiplication. When you multiply two numbers, even if you change the order, the answer will not change. 5 3s are 15. Now multiply 3 into 5. 3 5s are also 15. Here it will 5 tables. Here it is 3 tables. But in both the ways we get 15 as the answer. So commutative property is true for multiplication. Now we'll check for division. Is A divided by equal to B divided by A? Let us check. 4 divided by 2. What is 4 divided by 2? Till 4 comes, we should tell 2 tables. 2 2s are 4. But here 2 divided by 4, it is like this. 2 by 4. That is, we cannot divide 2 by 4 exactly. It is a fraction. So they are not equal. So just like closure property, commutative is true for addition and multiplication and not true for subtraction and division. Now third property is associative property. It is just like commutative. In commutative, we added only two numbers A and B. In associative, we are adding three numbers A, B and C. But what are we doing? This is left hand side, and after the equal to is called right hand side. On left hand side, we add A and B and then add with the third number. On the right hand side, we add the second number and third number, then add with the first number. See, we'll see an example. 2 plus 5 plus 6. Here 2 plus 5 we have to add first. What is 2 plus 5? 7 plus outside the bracket we have 6. Now 7 plus 6 is 13. Now we'll see the right hand side. Outside the bracket as it is. First we have to add 5 and 6 because they are only inside the bracket. 5 plus 6 is 11. Now what is 11 plus 2? 13. Are both answers same? Yes, so addition, however you change the order of the numbers, the answer will not change. So associative property is true for addition. Now we'll check the associative property for subtraction. Subtract the first two numbers, then subtract third number, then subtract the second and third number, then that answer we subtract from first number. So what is 3 minus 1? 3 minus 1 is 2. Outside the bracket minus 2. What is 2 minus 2? It is 0. Let us see the right hand side. 3 minus, what is 1 minus 2? Here itself, from 1 can we subtract 1? So I'm sorry, can you subtract 2? It is not possible. So you get the answer in minus 1. Then next we have to multiplication of integers and all come. So for present you just learn from 1 we cannot cut 2. So subtraction is not possible here with whole numbers. So we cannot subtract the right hand side, but the left hand side answer is 0. Therefore both the sides are not equal. Therefore associative property is not true for subtraction. Let us check for multiplication. See, we multiply 3 numbers, 6 into 4, then with 3. Then same 3 numbers, but we are only grouping different way. We are grouping first 2 numbers first. 6 4s are 24 into outside the bracket 3. 24 into 3 multiply. 3 4s are 12, carry 1. 3 2s are 6, 6 plus 1, 7. And what is on the right hand side? 6 as it is. Multiply 4 into 3 first. 4 3s are 12. Now 12 6 are 72. Both the sides we are getting equal. So associative property is true for multiplication. Then what do you think about division? Because it was not true for 2 numbers itself. So same way it won't be true for even if you change the order. Once you change the order, the property is not true for subtraction and division. For example, if you want to take 4 divide, this is first of all division is not even. When you divide 2 numbers, it's not even a whole number. Then even if you change the order, closure itself is not true. Therefore, all of the other property also will not be true for division. Let us see only right hand side if we need it for better understanding. 4 divided by 2 is 2 and divided by 3 outside the bracket. What is 2 divided by 3? It is 2 by 3. First of all, the number is not, it is not even a whole number. Then where we getting what about getting an equal number on both the sides? So division is not true for associative property, is not true for division. Now we'll see identity element. What is an identity element? With whatever number you add 0, we will get the same number. So the 0 is called the identity element of addition. The 0 has a special property. With whatever number, however big or small the number is, when you add 0, 5 plus 0 is 5, and 0 plus 5 is also 5. Whether you add 0 with the number or you add 5 with 0, we get the same number. And there is, so 0 is called the additive identity element of addition, and no identity for subtraction. Same if you see in multiplication, when you multiply any number with 1, we get the same number. As in addition, 0. When you add any number with 0, we get same number. But in multiplication, you multiply any number with 1, we get the same number. So 1 is called the identity element of multiplication. And as it is, as just like subtraction, there is no identity element for what? Division. Okay. Now we'll see the last one is distributive property. It is distributive property of multiplication over addition. A into B plus C. How are we going to distribute this sign? It is A into B. We have to multiply this A into B plus A into C. A into C. This is distributing multiplication over addition. Then same way we have instead of addition we have subtraction also. Distributive property of multiplication over subtraction. A into B minus A into C. They are called distributive properties. A into B minus, they are minus, multiplication over subtraction, multiplication over addition. If you want to check this, if it is 5 into 6 plus 7, what do we do? Right hand side. So let us check with an example. 5 into 6 plus 7. How to distribute? 5 into 6 plus 5 into 7. So let us finish the left hand side. 5 as it is, into as it is. We have to do the simplification within the brackets first. So 6 plus 7 is 13. And when you multiply 5 into 13, 13 5s are 65. And right hand side, it is 5 into 6 within the brackets first. 5 6 are 30 plus 5 7s are 35. 30 plus 35 is 65. See, both the sides are equal. So, distributive property of multiplication over addition is true. Next, we'll see multiplication over subtraction. It is 5 into 7 minus 6 is equal to 5 into 7 minus 5 into 6. So, it becomes 5 into 7 minus 6 is 1. And when you multiply them, 5 ones are 5. Here, multiply within the brackets first. 5 7s are 35. Minus as it is, 5 6 are 30. And 35 minus 30 is 5. See, all the answers same. Left hand side equal to right hand side. Therefore, distributive property of multiplication over subtraction is true. Now, we have studied about all the 5 properties: closure, commutative, associative, identity element and distributive. Now, let us just complete this table so that we can just check how much we have understood about the properties. Okay, are you ready? Now, first is properties are written in the side here: closure, commutative, associative and identity, and addition, subtraction, multiplication and division. Now, tell me quickly, closure, is it true for addition? When you add two whole numbers, we get a whole number. Yes, true. Subtraction, when you subtract two whole numbers, are we getting a whole number? No, because 3 minus 5. We cannot subtract 5 from 3. And multiplication, when you multiply two whole numbers, answer is also whole number. True. Division, when you divide whole numbers, it is not always a whole number. Sometimes we get it as a fraction, so not true. What is commutative? You changing the order. 3 plus 5 is equal to 5 plus 3. So is it true for addition? Yes. What about subtraction? No, we cannot change the order. Multiplication, can we change the order? 3 into 4 is equal to 4 into 3? Yes. Division, 3 divided by 4 equal to 4 divided by 3? Not possible. Associative, once it is true for commutative, it is true for associative. Subtraction, two numbers itself, it is false. So 3 numbers also false. Multiplication, yes, true. Associative for division, false. Identity, yes, there is an identity for addition. What is identity element? Is 0. And there is no identity for, do you have identity element for subtraction? No identity for subtraction and multiplication. Yes, yes, identity element is there. And which is the identity element? It is the number 1. 1 is identity element for multiplication. Then what about division? Division has no identity element. So just if you look at this table like this, so if you just have a glance at this table, it is summarizing all the properties for which are the operations the property is true and which are the operations the property is not true. We can easily remember and understand the concepts. So I hope you all have understood all the 5 properties of whole numbers. We'll see in the next video. Thank you for watching. Thank you.